Okay, welcome to lesson 27. Just as a warning, a lot of these answers are going to get a little bit crazy, but do your best. You can use a calculator along the way. I will talk you through the order of operations of how to type in your calculator, so you end up with answers that are correct and not all over the map. So we are moving into geometric sequences and series now. So when we did arithmetic ones last time, that's when the same number was being added to each term. Today we're switching and now the same number is being multiplied by each term. So it's the difference between addition in arithmetic and multiplication in geometric. So the common ratio, the definition of a common ratio, this is the factor that's multiplied by each term to get to the next term. So if we're multiplying each term by 3, our common ratio would be 3. If we were multiplying each term by 1/2, the common ratio would be 1/2. Okay, in order to find the first 5 terms of each geometric sequence, we're going to do just what it says. It gives me my starting value, and then it tells me what my common ratio is. So the first term is 1/3. Our common ratio is 2, so that means every term is going to be multiplied by 2. So 1/3 times 2 is 2/3. 2/3. 2/3 times 2 is 4/3. 4/3 times 2 is 8/3. 8/3 times 2 is 16/3. Okay, so those would be our first 5 terms. We're just multiplying them all by 2. Okay, same thing on number 3. We start with 4, but now we're multiplying each term by negative 1/2. So 4 times negative 1/2 would be negative 2. Negative 2 times negative 1/2 is going to be positive. 2 times 1/2 would be 1, so positive 1. Positive 1 times negative 1/2 would be negative 1/2. Negative 1/2 times negative 1/2 would be positive 1/4. And if you need to write each of those out along the way, then by all means do that, so that way you can see where each of those numbers come from. Okay, so that's just your geometric sequence, just going bit by bit, building it up on your own. Finding a specific term, just like we did in arithmetic, we've got a cutesy little formula, S of n, this is our specific term, equals a sub 1, your first term, times, there we go, your common ratio r to the power of n minus 1. Okay, where n is the term you're looking at. So if we're trying to find the 10th term of a sequence, sorry, you know me, in sequence versus series, of a sequence where the first term is 2 and our common ratio is also 2, then we could find S of 10 is equal to my first term, which is 2, times, r, which in this case is 2, to the power of 10 minus 1, since we're looking for the 10th term. So this would be equal to 2 times 2 to the 9th. Okay, order of operations here. You have to do, let me make sure I'm in a different color. You have to do the 2 to the 9th first before you multiply by 2. If you do 2 times 2 to the 9th, you're actually doing 4 to the 9th power, which is extraordinarily different. So do your exponential term first. Remember good old PEMDAS, parentheses, exponents. You're going to do your exponents first, then you'll multiply. So that being said, 2 to the 9th power is 512. So now we have 2 times 512. When we multiply those to get together, we get 1024. Okay, and that would be your final answer. So the 10th term in that sequence would be 1024. You can see since we're multiplying, our numbers are going to escalate and get very, very large or very, very small very, very quickly. 12th term, so here it gives us our first term and our r again. So S of 12 is equal to a sub 1, which is negative 3, times, oh my goodness, r. Oh, why do I keep doing that, you guys? My brain. Negative 1/3. I'm going to put in parentheses just so I can see what's happening here. To the n minus 1. Our n is 12 minus 1 would be 11. I'm just going to save a step and go ahead and subtract 1. Okay, so again, we need to do negative 1/3 to the 11th power, which is the same thing as negative 1 to the 11th power over 3 to the 11th power. So we still have our negative 3 out front. We've got negative, since it's an odd power, it's going to stay negative. 1 over 3 to the 11th power is 177, 147. 177,147. Okay, we have two negatives multiplied by one another. We know our answer is going to now be positive. Then we can reduce 3, this is like over 1, goes into 177,147 because we multiplied by 3 to get there. You'll reduce those out. So basically take this giant 177,000, divide it by 3. So your final answer would be positive because we had two negatives there. 59,049. 049. Okay, again, you're going to have, that's a really small number. You're going to have really big and really small numbers throughout this, but your order of operations matter. So to get this 177,000 number, I did 3 to the 11th power. To get that, and it goes in our denominator. Both the numerator and the denominator get your exponent. Okay, so then number 7, it gives me my first term. Wrong button. It gives me my first term, but then it also gives me my second term. So we're going to have to find our R value for this one. Okay, so we know a sub 1 is 8, yippity skippity. We know a sub 2 is 1/2. To find R, we're always going to do a2 divided by a1. This will come in very handy on the back page. Okay, so to find our R is going to be equal to a2, which is 1/2, divided by 8. If you remember to good old fraction rules, dividing by 8 is the same thing as multiplying by the reciprocal. So we're going to multiply by 1/8. It's the same thing as dividing by 8. So we get 1/16 is our R value. So in order to find S of 10, yes, we're looking for S of 10. So S of 10 is equal to my initial, which is 8, times R, which we just said is 1/16 to the n minus 1. So we're going to go to the 10 minus 1, which would be to the 9th power. Okay, again, fun is about to happen. 8 times, we're doing 1 over, because 1 to the 9th is 1. 16 to the 9th power has got a lot of numbers. It's 6, 8, you're not going to be able to read this, 7, 1, 9, 4, 7, 6, 7, 4, 0. Okay, that number happens to be divisible by 8, so we're going to reduce those numbers. We're going to divide both of these by 8. That 8 will reduce to 1. So our final answer will be 1 over that 68 trillion number. We're now settling down to just a mere 1 over 8 trillion, 589 million, just kidding, 934,592. That is basically 0, y'all. Okay, so that is finding specific terms in a geometric sequence. Again, watch your order of operations. Type those numbers in one at a time. Know that they're going to reduce. Leave your answer in fraction form, because if you try and put these in decimal, it's just going to give you like 0.1 times e to the negative 12 or something ridiculous. No, more than that. Okay, it's going to give you real weird numbers. I want you to kind of see it as a fraction so you can see how this geometric sequence like escalates so quickly, because this is an exponential. These are exponential functions. If you remember, those are the ones that start, let's get a pretty color. They kind of start low and then they go up crazy, or they start kind of thing and then they tank really fast. So we're in this rapid increase or rapid decrease.